Hey there. Today we are going to be looking at quadratic equations that are in vertex form and how we solve those equations for our x-intercepts. So first off, let's take a look at this example right here. Let's have f of x equals 2 parentheses x minus 4 in parentheses squared minus 50. And this is just the same as the standard or as the vertex form that we have seen before. But whenever we are solving out an equation for its x-intercepts, we want to turn this f of x right here into 0. So the first thing we are going to do is we're going to turn this part into a 0 and leave the rest of the equation the same. Now we have something that we can actually solve. And essentially, we are just using our inverse operations like any other equation that you've seen before. The key here, though, is we want to cancel out the things that are outside of the parentheses first. We want to cancel out this 2. We want to cancel out this minus 50. You can work it more than one way, but usually the easiest way is to cancel out addition and subtraction before you cancel out multiplication and division. So I'm going to start by adding 50 on both sides of my equation. So now I have 50 on the left side, and then that equals 2 parentheses x minus 4 in parentheses squared. Now we also want to cancel out this 2 since it's outside of the parentheses. So I'm going to go ahead and divide by 2 since this 2 is multiplied with the parentheses. I'm going to divide both sides by 2. So I get 25 on the left side. And then I have my parentheses with x minus 4 squared. So my next step, this is sort of the key step for these problems here, is we need to cancel out this power of 2. Now, in order to cancel out a power of 2, we need to square root both sides of the equation. So I'm going to take the square root of the left side, and I'm going to take the square root of the right side. The things that are inside the square roots are going to be the same as the previous line. So 25 is inside the square root on the left, and parentheses x minus 4 squared is the same as the square root on the right side. However, the one additional detail is we need to have both the positive and the negative of the square root of 25. So we need both the positive and negative here. That's because positive 5 times positive 5 is 25. But also, negative 5 times by negative 5 is also positive 25. So when we do our inverse operation here, when we take the square root of both sides of our equation, we need both the positive and the negative results here. On the left side, the power of 2 is going to cancel out with the square root. And so this is going to leave me with x minus 4 on the left side. Sorry, x minus 4 on the right side, because those cancel out. On the left side, square root of 25 is going to be equal to 5. But we keep the positive and the negative sign that we had previously here. So we have both positive and negative 5. And because we have both the positive and the negative here, that means we need to split into 2 equations. One equation will include the positive 5 and x minus 4. The other equation will include a negative 5 and x minus 4. So now I have 2 very simple equations, but the key here is that when we have that plus and minus sign on top of each other, that means we're going to split into 2 equations, one with just the plus and one with just the minus. Both of them still have the 5, both of them still have the x minus 4, but the plus minus sign gets split into one positive sign and one negative sign. Now that we have this, we can solve each of these equations out individually. So with the equation on the left, I'm going to add 4 on both sides. And so that will give me x equals 9. Because positive 5 plus 4 is positive 9, which is the equivalent of the x-intercept 9, 0. On the right-hand equation, I'm also going to add 4 on both sides. But now I'm adding negative 5 plus 4, which is going to give me x equals negative 1. So this will be the equivalent of negative 1, 0 for my x-intercept. And that's it. That's all we need to do for this problem because we have both of our x-intercepts here. Let's take a look at a second example that has a little bit more going on with it. So in this case, we have f of x equals negative 3 parentheses x plus 1 squared plus 54. So just like before, I want to start by turning the f of x into 0 so that we have something we can actually solve. And just as before, we are going to solve this out using our inverse operations. So I'm going to start by canceling out the 54. And since 54 is positive, I'm going to subtract 54 on both sides. So now I'm going to have negative 54 equals negative 3 parentheses x plus 1 squared. Just like the last problem, I now want to cancel out the number that's in front of the parentheses. I want to cancel out my negative 3. And since the negative 3 is multiplied with parentheses, I want to cancel it out by dividing. So I'm going to divide by negative 3 on both sides. So when this happens, negative 54 divided by negative 3 will give me positive 18. And then I will just have my parentheses x plus 1 squared. So now I need to cancel out my power of 2. I need to square root both sides of my equation. Well, when I do this, we should notice that the square root of 18 is not a whole number. The square root of 18 is not a perfect square. So we have to do something different. We have to simplify this square root. And if you've not watched my video on simplifying the square roots, I would suggest that you go do that because that will help this process out. But just like before, the right-hand side, the power of 2 is going to cancel out with the square root. These are going to go away. So the right-hand side, we will have x plus 1. The left-hand side, if we follow our process for simplifying this square root, we will end up with 3 square root of 2. And like I said, if you've not watched my video on simplifying square roots, I would suggest going and taking a look at that. But just like the last example we have both the positive and the negative of this square root. So we're going to have both the positive and the negative of this. So now, because we have both the positive and the negative, we can split this into 2 equations. So we have positive 3 square root of 2 equals x plus 1. And we also have one with the negative. Now, we do need to solve these out. We do need to get x by itself. So I'm going to subtract this one just as I did on the last several problems. However, you should notice that 1 is a different type of number than 3 square root of 2. These are not actually like terms. So rather than actually combining these together, we are just going to set them next to each other. So my answer here, my x-intercept is going to be x equals -1 plus 3 square root of 2. And over here, when I subtract, I get x equals -1 minus 3 square root of 2. So these are not like terms. We can't combine them together. We can't simplify this any further. This is essentially our answer. And if we wanted to write this as x-intercepts, we could write -1 plus 3 square root of 2, comma 0, and then -1 minus 3 square root of 2, comma 0. And so we have our two x-intercepts. They're not necessarily very simple because we do have extra terms here, but this is how we work it out. And this is our x-intercepts for this problem.